the area enclosed between the line y equals 2x and the curve x squared is equal to 4y is rotated through an angle about the y-axis. Find the volume swept out. Alright, I'm gonna ask you to make a genuine attempt at this. And I had worked it out before, and the answer I get, provided I didn't make a mistake, the answer I got was 536 cubic units. Alright, so see if you get that when you work it out. Okay, have you finished? Did you get 536 cubic units? Let's work it out and see what happens. You have the line y equals 2x, although it's a straight line. Sometimes, well, mathematicians refer to it as a curve. So they call everything a curve, whether it's straight or bent. Then you have the curve x squared equals 4y. Let's write it like this. 4y equals x squared, because you usually have y on the left and x on the right. So let's just write it that way. Alright. Now, you can transpose this for y and write it as y is equal to x squared over 4, or a quarter x squared then. Alright. Now what you want to do is sketch a little curve. And let's see what it might look like. So you have your x-axis. Let me bring the x-axis down a bit, make some space here. You have your x-axis and you have your y-axis. Alright. Now, when it comes to the curve and the line, let us say y equals x, no, y equals 2x. It would look somewhat like this. Right, it's steeper than the y equals x line, and then the y equals x squared. You know, y equals x squared would look somewhat like this, right? Y equals quarter x would have the same general shape. Let me draw y equals quarter x. It's just the general shape that we want. Okay. And the area enclosed would be this area under here, alright? Would be that area under the curve. Alright. I've gone a bit out too much here. So that is the area enclosed. Now, here, we need to find out what is going on in terms of the intersections. Where do the curves intersect? It seems like there's a zero intersection here, right here, but we need to find out where for x, the value of x, they intersect again. Now, I think since we are rotating about the y-axis, we also want to find out what y is at that point. Alright, so when they are equal, when the curve and line are equal, you know that y is equal to y. But in one case y is 2x, 2x is equal to, and the other case y equal a quarter x squared. A quarter x squared. Alright? Now, If you multiply both sides by 4, you have 4 twos 8x equals 4 by a quarter is 1 x squared. Let us rewrite it as 8x minus x squared is equal to 0. Factor out the x, you have x outside the bracket. 8 minus x is equal to 0. So what does this mean? Well, when you have x is 0, you have 0 times 8 minus x, which is 0 times 8 minus 0. But 8 times 0 times 8 is 0. So in one case, you can say that x is equal to 0. Our assumption was correct. X is 0. Well, it wasn't really an assumption. It should be obvious that x and y were both zeros, right? Y equal 2x, and also y equal a quarter x squared. They cross the origin, which is x equals 0 and y equals 0. What about the other value? Well, if you have this part equals 0, x minus 8 minus x equals 0, then you have x times 0 equals 0. That means you have 8 minus x equals 0. And when that happens, 8 is equal to x, so x equals 8. Alright, so x is 8 is the other value. And we say we want to find out what y is. Since you're going to rotate around the y-axis, I think that would be useful. So if you substitute 8 here, y equals 2 by 8, which is 16. Also, if you substitute it here, 8 squared is 64, and a quarter of 64 is 16. So both of them give you 16. Alright, now we have found the points of intersection. Now remember, we're going to rotate it about the y-axis. If you rotate it about the y-axis, what you'll be looking at is a shape looking like a bowl. Alright? And if you slice the bowl into several pieces like this, then you would be going from 0 to 16. So you're going from y equals 0 to y equals 16. And you have a change in y as you go up. So each slice would be, the change would be dy. So each slice is like a cylinder, you know. So if I draw the cylinder here, you have a radius r. The radius would be here. Now, what is that radius? That radius is the same as x. Alright? That radius is the same as x. Now here, the volume of each of these cylinders would be pi r squared h, but in this case, instead of pi r squared h, we know r is the same as x, so it's pi x squared, and the height is the same as a change in y. Let's use the uppercase delta here. It's really the uppercase delta we should use here instead of d. It's a change, the height is a change in y, delta y. That's the volume of each slice, each element. Right? Now, what is x? Thing is that we're going to have to rewrite this formula by saying x equals, right? So here we have going up, the x is changing, right? Now you're going to find out what x is equal to in this case. If you transpose the y equals 2x, you're going to get x equals y over 2. But you also have another one here. You have y equal, well, x squared equal 4y. So you would have x equals the square root of 4y. You also have x equals the square root of 4y, which is the same as 2 square root of y. Right? But let's keep it as x square root of 4y for now. Now, these are the values of x changing. Now here, when you add up all the various strips and you consider that there are several of them stacking up, you're looking at the sum. The volume is equal to, and by the way, let me put what I have here in a little box. I'm going to come back to it later. You're adding up from 0, from y equals 0 to y equals 16. The pi x squared delta y. So you're finding the volume of each of these little cylinders and adding them upwards from y equals 0 to y equals 16. Now, the limit as delta y tends to 0, that means you're making more cylinders, but the more cylinders, the thinner they must be. So the heights would be approaching 0. The limit is y equals 0. So the volume equal to the limit as you add from y equals 0 to y equals 16 of x squared delta y is going to be the integral. Once you put the limit in there approaching 0, when it approaches 0, use the integral sign from y equals 0 to y equals 16 of x squared, and instead of putting delta y, you say dy. So you're integrating, right? Now let us use the first x equals, the first formula here, x equals y over 2. Now the volume is equal to, now here, oh by the way, look at this. You have a difference between the x squared and the y over 2. Alright, I should have drawn that at first. There's the y over 2, the black one, and the blue one is the x squared, right? Now, let's say we have two volumes. You see the first volume, call it volume 1. I shouldn't put the 1 there, volume 1. What we're going to have is the volume from the y-axis to the line. So if we consider the y-axis here and the line, we rotate, this is what we would have, right? And then for volume 2, we have our y-axis and our x-axis. Oh, by the way, let me draw the curve a bit thicker. Let me use a straight line too. Or not the curve, the straight line. So the volume swept out by the straight line would look something like this. That's that volume there. Then the volume by the curve would look something like this. So if we put them together, what we have is the volume, that bowl formed by the curve, right? And this volume here. So we would be looking at the whole volume of the bowl and removing the volume of a cone inside, right? So it's like you use a clay to make a bowl looking like this, and then you use the knife to cut out a cone from the inside, and what you're left is the volume that we're finding. All right, so we're going to subtract the volumes to make V. What should I call it? V total. Alright, let's just call it V. V is going to be V2 minus V1. Because V2 would be larger. It's a bowl, and then V1 is the inside that you cut out. So in this case now, what we have is V1 is going to be the integral from y equals 0 to y equals 16 of. Now, what we have is the straight line. Let's write it as it is first, x squared dy. But pi, my gosh, I don't want to forget the pi, you know. It's pi. How could I leave out the pi? The pi is always there. It's pi r squared h. So it's pi x squared dy, which is the integral from y equals 0 to y equals 16 of pi, but what is x in this case? X is y over 2. So it's y over 2 all squared, y over 2 squared dy. That is volume 1, you know. Then volume 2, let me write volume 2 here. Volume 2 is going to be the integral from y equals 0 to y equals 16 of pi x squared dy, which is the same as integral from y equals 0 to y equals 16 of pi. What is x in this case? X is square root of 4y. The square root of 4y dy. But let's simplify this a bit. So volume 2 is equal to the integral from y equals 0 to y equals 16 of pi. But remember now, square root of 4 is 2. So it's 2 and the square root of y. But the square root of y is the same as y to the half dy. When you're going to integrate, you want it as written to a power instead of the root over it. So now, the volume that we want is going to be one minus the other. It's going to be the integral from y equals 0 to y equals 16 of pi by 2 y to the half dy minus the integral from y equals 0 to y equals 16 of pi by, what was it again? Oh, so it should be squared. My. I wrote the x in the second part, but I didn't square it. It's squared, you know. This should be squared. Right. So, but the thing is, what you have is square root squared. So the square root of 4y, r squared, is just 4y. You see how easy it is to make a mistake with these, man? Right. And if I was under exam pressure, I probably wouldn't remember that I neglected to square it. It's 4y dy. So this should be 4y then, dy. Minus, and then pi, y over 2, right, v1, pi y over 2 r squared, which is y squared over 4 dy. Okay. Now you could integrate each of them separately. We run out of scrolling space, you know. Yeah, we could integrate each of them separately and minus. Well, let's do it like this. Equal. Now this is the same as if you factor out pi and consider the integral of everything from y equals 0 to y equals 16 off, and then you say 4y minus y squared over 4 dy. You could do it like that. Alright? I'm saying you could integrate this and then integrate this separately. Then what you get, you subtract them. But remember, since the boundaries are the same, you could just combine them. Alright? And since we have pi in both, we just put the pi outside here. Alright, we have run out of scrolling space, so let's draw a line up and then we continue our work on the right side of that line. Alright. So, what does it say again? Volume is pi, integral from 0 to 16. So, our volume is pi, integral from y equals 0 to y equals 16 of, in bracket we have 4y minus y squared over 4. Okay, so we have 4y minus y squared over 4 dy. Alright, so volume is equal to pi. Now let's do our integration. In the bracket we have 4y, so we're going to have 4y squared over 2 minus, this is going to be y cubed over 3 by 4. Oh, we should really use square brackets. going from y equals 0 to y equals 16. Alright? So, you see what's happening there. Make sure you're following, Alright? So, volume is pi times upper boundary first. It's 4 times 16 squared over 2 minus 16 cubed over 3/4 12. Alright? Minus, open bracket, lower boundary now, 4 times 0 squared over 2 minus, and I could have cancelled out and make 2 into 4 2 before, but let's continue. Minus 0 cube over 3/4 12, right? So volume is equal to pi times. Alright, so what happens here? 2 into 4, 2, and 2 into 4, 2. 2 times 16 squared. What is 16 squared again? 16 squared. It's 256 now? Let me see something here. 16, just to make sure, to the power of 2. Right, 256. So that's 256 minus, and then 16 cubed now. If we had 16 to the power of 3, we get 4096. 4096, right? Minus. Now, what do you get for this part? Oh, over 12, right? What do you get for this part? Well, 0 squared is 0, 0, 4, 0, 0 over 2, 0. Minus 0 cube is 0, 0 over 12 is 0. Alright, so we don't have to worry too much about that part. Everything goes to 0. So volume is pi times 256. It's 2 by 2, 56, 5, 12. Right, 2, 6, 12, 2, 5, 10, 1, 11, 2, 2, 4, 1, 5. Minus, and then we have 4096 divided by 12 gives us 341. And we have 0.333, 341.3. Alright, 341.3, something there. Alright, so when we subtract them, volume is equal to pi times what now? We have 512 minus that equals, we have 170 something, 170.666, 0.667. So when we multiply that by pi times that gives us, okay, we have our 536 unit cubic units. That was the answer, right? That's what I had said I got earlier. Alright, so that was the answer. As I said, you could, if you want, integrate each, find a number, integrate this, find a number, subtract them, right? Integrate each and find a number and subtract them. with integration you can combine them, right, like that, and you get your answer here. Alright, I'll see you in the next video.